Good morning and welcome to Nature Walk, the podcast where we delve into the wonders of the natural world. I'm your host, David, and today we're going on a fascinating journey to explore one of the most intriguing aspects of animal behavior, breastfeeding in orangutans. In the lush rainforests of Borneo, a team of researchers has made a remarkable discovery about how long these intelligent creatures nurse their young. It's a story that not only sheds light on the life history of orangutans, but also underscores the importance of conservation efforts to protect these critically endangered animals. Imagine observing a mother orangutan and her baby in their natural habitat, watching as they interact and care for each other. For years, scientists have been trying to determine how long orangutans breastfeed, but this is no easy task. It requires patience, dedication, and a deep understanding of these animals' behavior. However, a team of innovative researchers has found a unique solution to this problem by analyzing the feces of wild Bornean orangutans. This technique, known as fecal proteomics, involves searching for specific proteins in an animal's poop to determine what it's been eating. In the case of orangutans, the presence of milk-specific proteins indicates that a young orangutan is still drinking breast milk. By gathering fecal samples over 2.5 years, the researchers found that all 20 samples from orangutans under 6.5 years old contained these proteins. This remarkable discovery suggests that orangutans have one of the longest breastfeeding periods among mammals, with young ones nursing for at least 6.5 years. But what's even more astonishing is that the researchers found a significant correlation between milk intake and the presence of probiotic bacterial proteins in the orangutan's guts. In other words, the more milk an orangutan drinks, the healthier its digestive system becomes. This prolonged breastfeeding period likely plays a crucial role in the high survival rate of orangutan babies and their slow reproductive approach. However, with Bornean orangutans being critically endangered, it's essential that we take immediate action to safeguard their rainforest habitats. The loss of these incredible creatures would not only be a tragedy, but also have far-reaching consequences for the entire ecosystem. As we explore the natural world on this podcast, we're constantly reminded of the intricate connections between species and their environments. The story of orangutan breastfeeding is a testament to the remarkable adaptations that exist in nature and the importance of preserving these delicate balances. We'll be right back with more fascinating stories from the natural world on Nature Walk. Welcome back to Nature Walk. Today we're exploring some fascinating stories from the natural world, and I'm excited to share this next one with you. Imagine a time when our ancestors used materials found in nature to craft tools for their daily lives. We often think of stone tools as the primary implements of our ancient relatives, but it turns out they were much more resourceful than that. Researchers have been studying the remains of Neanderthals, and they've made some remarkable discoveries about the tools these early humans used. It seems that Neanderthals didn't just limit themselves to stone, they also used materials like wood, plant fibers, hides, and even bones from large animals like mammoths and elephants. But one of the most surprising findings is that Neanderthals used rhinoceros teeth as tools. Yes, you heard that right, rhinoceros teeth. These early humans would have seen using such materials as mundane, but to us, it's a remarkable insight into their resourcefulness and adaptability. The researchers conducted experiments to see how these rhinoceros teeth might have been used. They found that the teeth could be used as soft hammers for knapping or retouching stone tools, or even as anvils paired with harder stone hammers or cutting tools. The enamel on rhinoceros teeth is incredibly hard, making them ideal for withstanding the pressure and shock of these tasks. What's even more remarkable is that the researchers were able to work out how Neanderthals might have held these teeth while working, giving us a glimpse into their daily lives. It's a testament to the ingenuity and creativity of our ancient ancestors, and a reminder that there's still so much we can learn from the natural world. As we continue to explore the fascinating stories of Nature Walk, we're reminded that the natural world is full of surprises and wonders waiting to be discovered. Welcome back to Nature Walk. As we conclude our journey through the fascinating stories of our planet, I'd like to take you to a region where the effects of climate change are being felt in a rather dramatic way. The Brooks Range in northern Alaska is experiencing a phenomenon that's turning its rivers orange, and it's not just a matter of aesthetics. This change has severe ecological consequences. As we delve into this story, let's start with the big picture. The Brooks Range stretches for approximately 600 miles, and within this vast expanse, scientists have noticed a peculiar pattern. At higher elevations where rocky ground contains pyrite, also known as fool's gold, the thawing of permafrost is triggering a process called acid rock drainage. This occurs when minerals and rocks are exposed to oxygen and water, degrading the water quality. When pyrite meets water, it breaks down into iron and sulfur, creating sulfuric acid, sulfate, and other toxic metals. As the iron-rich water mixes with more oxygen, the iron turns into rust-like particles that color the water and stain the bottom sediments orange. It's a fascinating yet alarming process that's unfolding before our eyes. However, at lower elevations, the story takes a different turn. The landscape is covered with wetlands that are changing shape and expanding downward as the permafrost melts. In these more soggy places, the soils are low in oxygen, so instead of breathing in oxygen, microbes in the water, mostly bacteria, are taking in iron. This process converts iron into a water-soluble form that seeps into streams, resulting in rusting as it meets oxygenated surface water. The team of scientists studying this phenomenon has made a crucial discovery. There's a delayed effect that could help predict future contamination. During the summer, the active layer of soil thaws to its deepest point and then refreezes before winter. The iron released during one summer thaw can become trapped and then flushed into rivers the following year. By studying long-term ground temperature data and stream chemistry, scientists can anticipate increases in metal levels. This means they can use ground temperatures to help predict water quality in the future, giving communities downstream a heads up and allowing them to work hard to protect the places that are still safe and less vulnerable to the rusting. As we reflect on this story, it's clear that climate change is having far-reaching consequences for our planet. The rusting of Alaska's rivers serves as a stark reminder of the interconnectedness of our ecosystem and the importance of understanding these complex processes. That's all for today's Nature Walk. Remember to like, share, and subscribe. And until next time, keep exploring your natural world.